Hey, what's up and how's it going? This is Toby, and in today's video I'm going to show you how to create this awesome AR experience for Snapchat using Lens Studio. And Lens Studio is quite a versatile and interesting tool because it not only allows you to create Snapchat filters, but actually web AR experiences as well as native experiences for iOS and Android. For today's tutorial though, we are going to build a Snapchat filter first, and if you want to see more tutorials on that, please write a comment below. In today's video we're going to learn actually quite a lot, so we're learning how to do AR meshing, how to import 3D models, how to work with animations and states, how to do hand tracking, how to create buttons, and how to interact with 3D models using hand tracking. So it is a feature-packed tutorial, and without any further ado, let's get started. So to get started, we of course first of all need to download Lens Studio, and you can find this on ar.snap.com, and here go ahead and download it. And for later on, if we want to deploy and try the effect out, we'll of course also need a Snapchat account. So if you haven't got that yet, then now is a good time to create it. So after downloading and installing it, we can open up Lens Studio, and I'm currently using Lens Studio version 5.4. So just that you guys know, if you watch this in the very future, maybe even a few years from now, maybe some things will have changed. So this is the version that I'm currently using. And also a little advice here: if you want to kind of see what lenses you have published and so on, you can click on the top right corner here, and then you can probably log in with your account if you haven't already. And then you'll be forwarded to this site where you can manage all the published lenses and get your insights and so on. And also you'll be able to host WebXR or Web AR lenses and deal with Camera Kit. So back in Lens Studio, let's create a new default project. So simply click here on default. And now we're here in the standard view. So this is our scene, and with our middle mouse button and with our right mouse button, we can move around, and then we can select objects. And then on the top panel here, we can click on, for example, move, rotate, scale. And I think this is all combined, but yeah, we can then again go ahead and rotate stuff. And then of course with Command or Control Z, we can go one step back. So then you can already see on the left side here our scene hierarchy, and these are all the objects that are currently within our scene. And down here is the logger, which will put out error messages if something is not going right. And we can also go to our asset browser, and these are all kind of the objects and prefabs that we can then drag into our actual scene. On the right hand side we have an inspector, and if we click, for example, the camera, we can see the different attributes and components it's attached to, very similar to Unity. And we can also add components here. So this is pretty much what these objects consist out of. So a transform which controls the position and rotation and so on, and the camera values. So then we also have the preview window, which will allow us to test things out. We do have a lot of videos here. We'll be probably using some of those outdoor world tracking examples, but we can also actually choose to use our webcam. Or we can also use here the preview window, which will allow us to move around in a virtual environment and test out stuff. And we can choose the sunlit room or some other rooms here, so we can also test out different lighting conditions, which is quite nice. And if we want to reset our preview, we can use this reset button here. And we could also potentially reset our camera location here, so that we pretty much start even with the camera and so on from the beginning. Then there's the asset library and the project settings, which you can find up here. So project settings, pretty straightforward. You can set up what this lens is made for, and then also define an icon and a preview and so on. And also basically state if this lens should work on front and back camera or only on the rear camera. And then there is the asset library, and this one is really important because we can use it to import some kind of prefabs into the scene and use them to get started a lot faster. There are a lot of great templates in here. So then let's also take a look at the buttons here at the top right corner. So we do have the Gen AI suite. We do have the possibility to connect our spectacles. We want to do that today. And we can also send to all devices. And this is most important here. We can pair a new Snap account and then scan this with our Snapchat app on our phone, so that we do have our phone connected, and we can then send our lens to this device and test it out, so we don't have to even plug it into our computer. And publish, we're going to take a look at that later on. All right, so then let's go ahead and set up the world tracking and the meshing. So for that, let's click on the camera object and let's add a component. And we want to add a device tracking component and set the tracking mode to world. And so now we do have the functionality to actually track basically our camera movement and a possible depth met here. So, well, that we have more understanding of our scene. So then next up, we want to add another AR component, which is the world mesh. So let's enter world here and let's add the world mesh. And this will actually do AR meshing as we would know it from, well, for example, Unity. So if we reset our scene here, if we move around, we can see that, well, objects are being represented or rebuilt within a AR mesh. And it's quite easy and quite cool to do this. So it's just a simple click, and we do have a lot of scene understanding here. And we can use this mesh for any kind of things. We could put a special texture on there, and we can also use it to place our objects and also potentially use it for physics. By the way, if you would now send this to your device, you could actually test this immediately working, and you could see that the meshing does actually work quite well. The thing is that, of course, as this is quite resource intense, it will work better on later phones. I personally do have an iPhone 11, and while it is working quite good, I would guess that a later phone will definitely yield better results here. So for our example here, it is enough to just catch shadows and basically place objects. So this is the kind of use case that we have for the AR mesh. And for that, in our asset browser, let's add the matte shadow material here. And this is specifically doing what we want. So we can go into our world mesh and then drag on the matte shadow material. And we can see that, well, we can't see the mesh anymore. And this is because it's just being hidden, and it will only cast shadows in the future. So one final setting we need to select is the mesh shadow mode, and we want to set this one to receiver. Cool, so next up, let's add a UI button. And for that, we're gonna click on plus, and we will add a screen transform. So screen transform, so add this one. And this will allow us to place buttons. So let's click on the screen transform and let's add a UI button here, like this. And we can already see that it's kind of taking the whole screen here. And to better adjust it, we'll need to add a new window. So we're gonna go up, window, I think editors maybe, yes, 2D editor. And we can then drag this one into our middle view here, and this will make it easier to basically define the boundaries of our button. So let's go ahead and put this button somewhere at the bottom left corner. So simply use well, this kind of helper squares here to define the boundaries, like this. Awesome. And the button text, let's set this one to toggle. So this one is going to be a debug button actually to see if our meshing is working. So now if we go back to our preview, we can see that the button is somewhere in the left bottom corner. We can also actually go ahead and from no simulation, for example, select a phone. We can see around the well, size and position where the button would potentially be on a actual phone. So next up, let's add another component, which is quite important to our button, which is the behavior script. So the behavior script will make it easier for us to, well, trigger an event, as it already says here, on something happening. So we do have in our trigger certain events on like a touch event or on start, on enable, on awake, update, which is called then about 30 or 60 times per second. So on any frame. And we do have so other events too. We can basically use this to say, okay, if this kind of event happens, so if basically, for example, there's some kind of interaction, or if there's the distance from this object to another object reaches certain value, Then we want to shoot out an event, and based on that, we, for example, want to change a color or start an animation or anything. So this is a great way to shoot an event based on some kind of trigger which has been started inside of our AR app. All right, so to make this work, we'll have to edit the event callbacks on the UI button. And as a callback type, we're going to choose the behavior script. And we want to say that on press down, so if the button is pressed down, we want to add a value. And we're gonna go ahead into our orthographic camera, and this one is responsible for our UI. So it's not the world camera, it's just for the 2D elements basically, into our full frame region, so our screen, and then on our screen transform, and we want to select the behavior script here, like this. All right, so what will happen now if we hit the toggle button, then we're going to shoot this behavior script. So we do not need any kind of touch event here. Basically, the touch event is also being fired in this case if we would touch anywhere on the screen, so not only on the button. We're gonna set this one to none because it's being triggered anyways. But what we want to do is we want to set a response type, and we want to send a custom trigger. And we also do have some stuff here like set rotation, position, scale, and we also have to can also set a material. But I just want to show you guys how to do this within a script, so that might be a bit more helpful depending on what kind of AR lens or application you want to build. So just call this one maybe toggle mat. So toggle material. We also only have like one trigger in this whole experience that will toggle some kind of material. So I think this one is being fine in regards to its name. So next up, we're gonna create a new script. And so for that, let's create a new folder, and let's call this one scripts. And let's go ahead, click on this, add new, and let's add a new JavaScript file. Let's call this one toggle mesh material, like this. And we can do a right click and do a double click here, and this will open this one in our internal editor. By the way, if you double click this, it might open in an external editor like VS Code or so. You can change this one in the project settings, and sorry, not this project settings, but in the Lens Studio preferences. Going to the editors, and then you can say always open in external editor, JavaScript, TypeScript. So if you uncheck this, we'll go to the internal editor. If not, then we go to the external editor. But you could also do a right click and say then open in external editor or open an internal editor depending on your preferences. So let's do a little bit of coding to change the mesh material on runtime. If you want to know more about well, how the Lens Studio API works and what kind of code you can write, what kind of API you can reference, you can go to developers.snap.com. I'll also put this link in the video description, and then you can go to either the API reference, or you can go down here to scripting, and you'll have a little bit of an overview, some examples about the events, but of course you also have the full API reference here. So you can go, for example, to the Lens Studio scripting API like that, and then you have kind of all those things here, such as transform or events and stuff like that. So you can do a lot of reading and find good stuff. There's also actually, which is quite interesting, within our Gen AI suite, we do have the basically a chat that we can use here to say, hey, how can I switch materials at runtime, let's say. However, I gotta say that this script is still a bit limited in regards to how much you can copy paste in here. All right, so can be like very simple questions, and it will give you an answer on how to code this, but it's also not always right. So yeah, I would recommend test it out, but you also use the documentation. So back to our scripting editor, let's first of all define some inputs, and if you're a Unity div, this is the same as a serialize field. And we're gonna say we want to take a component, like this, and we want to take the render mesh visual, which is kind of the renderer where the material is attached, and let's call this one mesh visual. And then next up, let's get another input here, and we want to set this to a material. So asset.material, and set this one to the debug material. So this will be the colorful one. And finally, let's create another input here, and let's take another material, and let's make this one a Shadowcatcher material. So this way we can change it. So then we also want to create a new variable. Let's call this one is debug material. And this one's going to be false because we're going to start with the Shadowcatcher. And finally, let's write a quick function, and let's call this one change render mesh visual material to make it super expressive. So let's do a little print here, so we just make sure that things are working. So let's enter print, and let's call this one change render, or maybe just copy and paste the function name so we know that it's being run. And we want to say that, so if we're not using the debug material currently, then we want to access the material of our render mesh visual, and to access these serialized variables up here, we need to say script. So this is how we access them. We can go to the mesh visual, and then we can go to the main material, and we want to say this one is going to be equal to the script debug material. All right, so then we also want to set is debug material to true. And else we're going to say that the script mesh visual and then the main material, we're going to set this one to the Shadowcatcher material. And then of course we want to say that the is debug material equals false. All right, so now we finally need to have the connection to our event that we created in our behavior script. And for that, we want to go to global, which is kind of the static. So if you were in Unity, this would be like the static event here. And we can go into the behavior. I think it's the American behavior here, so beware of that, behavior system. And we want to add a custom trigger response. And our trigger, how did we call them? Let's go back to the behavior script here. In our scene hierarchy, call this toggle mat, like that. And let's copy paste. And then we're gonna select the function that we want to bind. So this is the change render mesh visual material function. Finally, just a quick semicolon, and then let's test if this works. So first of all, we'll need, of course, to add our script. So let's create a new empty object. So it's a scene object. This is like an empty game object. And let's call this one scene logic. And let's simply add the toggle mesh material here. So then we'll need to drag in our mesh visual, which is this one here. And then we have our two materials. So the Shadowcatcher material, and there's the standard world mesh material like this. All right, so then I think we don't need a reset. Let's check the logger if we do have any kind of error here. I think we're good. So let's do a little refresh here. Let's toggle. And yes, we can see that basically the mesh is changing the material. So this is how you create buttons and how you can change materials at runtime. And this is great for debugging later on, but also if you want to create some kind of different buttons, then you know how it works for any kind of AR app that you want to build. So the next step is to place a 3D model in our scene. And for that, of course, we'll need a 3D model at first. Who would have thought? And for that, we can go to sketchfab.com or any other site that has 3D models. And if you're here on this page, you can simply go ahead and choose for 3D models. downloadable and animated, for example, because we'll also learn how to trigger animations later on. And then you could go to categories, for example, animals and pets, make sure that date is all time. And then you can go ahead and search for something that you like. But again, you can basically choose anything. I would recommend, I think it's only possible to actually choose FBX and GLB as a file. So for example, I got this hair here. And this one, if I click on download model, we can see that the original format is FBX. And also that is only 1 megabyte in size, which is really nice because I think a whole effect can be 8 megabytes. So you got to really take care that while the file size is not too big, and also that FBX or GLB is the original format, because if we will convert it to some other format, let's say this would be, I don't know, Blender as an original format, and we would say convert this one to GLB, we might have some issues with importing the animations. At least this is my experience. Of course, you can any given time import a Blender or whatever model into Blender and then go ahead, do adjustments and then export it. But for the sake of this tutorial, we're going to stay with the easy way and we're going to simply download it and import it into Lens Studio immediately. All right, so then let's go ahead and download the 3D model in the FBX file and save it in our downloads. So then let's go back into Lens Studio and take the unzipped hair animated file and simply drop it in here like this. And well, this looks all good, so let's accept. Awesome. So now we got the hair animated folder here, and let's open this one up and we can see source and textures. We do have the rabbit with its animations seemingly. So these are animation files as well as the textures. So let's go ahead and see what happens if we drag this one in our scene. And then let's go ahead and move a bit around in the animators. So, oh yeah, we can see it's pretty big. Let's go back into the scene view here and take a look at it. It looks pretty big and also looks pretty wide. So what I see here is that somehow in this FBX file we still got a light going on. So this one has an intensity of 1000. This is a bit much. So let's go ahead and delete it by clicking backspace. So this is looking a lot better, but somehow the texture is missing. So let's go ahead and fix this. Let's click on the rabbit mesh. So this is the armature, kind of where the animations go. We can see that we have this purple material and the emission material. So then let's go ahead and go into the rabbit animation. And what we'll need to do in order to access the materials here, so the emission and purple material, so we need to unpack this one once more. So let's do a right click and click on unpack like this. And so now we do have another folder where we can actually access well, all the materials and so on. And now we can go ahead. So we have now our animated source animation, and then in the materials, in the, I think it might be the purple or whatever material here. So we got the emission and the purple material. Let's quickly check when we change on the right hand side here the base color, what happens. So these are the eyes, and then the emission might be the body. Let's see. Yes, so this is the body. Perfect. So let's go ahead and actually choose the base texture. Let's click on that. And let's drag in the texture rabbit and like this. And so now we have our texture on here. And for the other material, for the purple, we're going to take the eye transparent material. But first of all, enable the base. Oops. First of all, let's enable the base texture like this. And well, this looks scary. And then let's take the eye transparent and drag it in here. So then let's also go ahead and set the blend mode to, I think, multiply. So in this way, we do have this kind of, well, reddish background here for the eyes. So now it pretty much looks like the one we got in Sketchfab, and we can begin placing it down. Cool. Let's first of all go ahead and actually rename this one, and let's simply call this rabbit animal so that we know that this is the one that we want to use. And let's actually drag this one into our asset browser and pretty much create like a new prefab. So now we have it here. Pretty good. All right, so now we can actually delete the rabbit from our scene here. And we do still have it as a saved prefab. So if we will now redrag it in our scene, we have it back here. So next up, let's implement the placement logic. So at this point in time, let's actually go ahead and save our project by going to File, Save. And now we need to, well, define a new folder. Let's call this one simply tutorial 1. And let's save this as hair on hand, maybe. I think that's a good way to describe what we're doing here. And there's the save trace. I'm actually not 100% sure what this is for. I always just click on cancel. I think it might be to, you know, do some debugging and stuff like that later on. But I always get this weird pop-up message and I couldn't yet figure out how to stop this. So next up, let's create a new script for the placement. And for that, we're just going to create a new JavaScript file. And let's call this one place hair in Word. Like this. Let's drag it into our scripts folder. And let's open this up in the script editor. So next up, let's go ahead and first of all do the input. So then of course we want to begin with some serialized fields. So we're going to say add input. We're going to take the asset and we want to take a object prefab here. And we can call this one hair. And next up, we also need some more inputs. So we're going to take the camera. We need the camera component to shoot a raycast, so kind of a laser beam from the camera. And if that one hits the world mesh, then we will instantiate our hair at this position. And then finally, of course, we want to go ahead and take the screen transform component. And this is actually what we'll use to block raycast, a laser beam, if we'll actually hit a button, because we don't want, if we hit this debug or toggle button for the mesh, to then instantiate the object. So let's call this one UI elements. And then we will also create a new variable and we can call this one should spawn, make this one to true. And this is because we'll only spawn the hair once and not more often. Of course, you can do it as you wish. So let's create, first of all, a function that we want to call onTap. And we're going to take some event data. We're going to bind this to a tap event a bit later on. So basically, if we tap the screen, then we're going to get the tap position. So we'll assume that this event data will basically hold the tap position. And there's also some information on that in the documentation. I'll put some info in the video description. And so we're going to get the tap position, which will be then a vector. And if we should not be able to spawn, then we just want to return, because then we don't want to spawn a second or third or whatever time. Then we also will check whether, well, the tap is over a UI object, like this, and we're going to take the tap position, and we're going to write this function a bit later on. So we're just going to then print, well, tap is over UI position, like this, or UI object maybe. And then we're gonna return. So because we also don't want to place anything then. The next up, we're gonna get the near position. And this is going to be from our camera. So we're going to get the screen from our camera. We'll take a pre-made function, which is the screen space to world space function. So this is going to transform a vector 2, because if you tap on the screen, basically there's no depth, right? We're going to take this screen point, we're going to transform it to a vector 3. We're going to take the tap position like that. And then we're going to take the script, so from our variables up here, our serialized input variables, we're going to take the camera, and we're going to take the near attribute. So we kind of are going to take, a range in which we want to shoot the ray, so from a start position to an end position, in order to find a potential mesh hit. So then we're going to take the far position, so kind of the end then. So this one we're going to again take our camera and screen space to world space. We're going to take the tab position once again, and then our end will be the camera and far, like that. So then we're going to take the going to do the raycast. So let's call this one hit position, a new variable. And let's go ahead and access our camera once more. And we're going to get the scene object. So we're going to take the camera object as it is. And we want to get a component here. And this one is supposed to be of type device tracking. So the component.device tracking. By the way, if you create a custom script, you can unfortunately not at this point, I think. If you know it better, please let me know, get it as a component. So we couldn't say get component place here in world, which would be super handy. But those are, I think, predefined components that you can get here. And then we're going to do a raycast world mesh. And we're going to take the near position, so the starting position, and the far position, which is going to be the end position. And now you might ask yourself, hey, how do I even know that this device tracking has a raycast world mesh? So how we can find this out? I mean, we added the device tracking to our camera object a bit earlier. And if we would now go ahead and ask, for example, in the Gen AI suite, or we could go even to the documentation. And then in the documentation, we could search for device tracking, which is the component that we added. And we do have the device tracking module and so on. So let's click on this built-in device tracking here. And now we can see the class and what it does. And we can also go ahead and go to the properties and method. So we do have, for example, the raycast world mesh method here. And then we'll take from to, and we can see that we can use this method. So it does not have, the suggestions like you would expect in Unity and C#. We do have this pretty detailed scripting API here, which with a bit of, researching will give us all the important methods that we'll need. So feel free and be, explorative within this lens scripting API if you want to know what possibilities you do have. All right, then back in the editor, I just saw that, we named this hit position. This is of course wrong. These are the hit results. So then let's go ahead and say if the hit results like this, if the length of this array is greater than 0. So if we hit anything and in our array we do have multiple or at least one hit result, then let's actually get the first hit result. So let's create a new variable. Let's call this one hit, and let's go into the hit results and let's take the first one. So let's create a new variable and let's call this one new object. And let's go ahead into our variables up there, and let's go and say script here, so the one that we want to spawn. And then we will say instantiate. And then within the brackets here, we're just going to say script.get scene object, like this. All right. So by the way, I'm just seeing that there's a little mistake here. It's actually the screen position, of course, and not the screen position. So maybe there's also a position, but we don't want that. And then, of course, we want to set the position. So we're going to say new object. And we can then go ahead and say get transform, like that. And then we want to go ahead and set the world position. And we want to set this one to the hit dot position. So wherever we, that tab hitting into the actual surface. And so then let's also add an else, and let's call this one simply no surface detected at tap position, like that. So I actually already commented this code out here because now we can test if things are working first and foremost. And for that, let's go ahead and actually add the tap event. So let's go ahead and say tap event. So create a new variable, tap event, and this one is going to create a new event based on the global tap event. So if the screen is being tapped, and we're gonna bind this event to our onTap function. So, and the arguments are being passed automatically. So let's first of all try if this is actually working. So let's clear our logger here, and let's go ahead and then move a bit around. Is there mesh? Yes, and we clicked, and we can actually see that, well, the hair has been placed. If we reset this one and we click somewhere here, well, it's probably positioned somewhere where it should be. However, the issue might be, well, that it's just really, really big. So let's go ahead and actually change then the scale of the hair so it will be a bit better. All right, so in order to reduce the scale, let's go into our new object, and we're also going to get the transform. So we're going to do this programmatically. Going to set world scale. And we can, for example, create a new vector here. So let's first of all say let scale vector. I'm going to say this is a new vector 3, like that. And it's going to be 0.1, so like this, 0.1, 0.1, and 0.1, that. And let's set the world scale to the scale vector like this. Little semicolon here. And now if you're going to test things out in our preview, I'm going to reload everything. Open up our logger. So let's toggle. We can see that the hair is reasonably small. Cool. And actually maybe do this to 0.15 or something, so that it's a bit bigger. And yeah, I think this is good. So one thing we can see here is that we can also still place multiple rabbits, and also that the rabbit doesn't cast any shadows. And this is something we can fix quite fast. Simply go into our rabbit animal here, do a double click, and we're gonna go into the rabbit mesh shadow mode, caster, and another caster. Now we're gonna go back into our scene, into the preview, and we're gonna reload everything. And then we're gonna go into our lighting. We're gonna enable shadows, and always make sure then if you change something in the prefab to hit apply. And after that, we can simply go back to our scene. And now if you go to our preview, and let's just reset stuff here like that, then let's look around a little bit and place the rabbit, and we do have shadows on, which is pretty nice. All right, so then we can go on and finish our script. So first of all, let's uncomment here our function that we wrote, the custom function, if the tab is over the UI object, and let's write this one next. So for that, let's create the function is tab over UI object, and we're gonna take in the tab position like this. And we're simply going to do a for loop. So we're gonna fill out these UI elements a bit later on. And we're gonna say that for I, which equals 0, as long as I is smaller than script.UI elements.length. And we're also going to iterate on I. Then, well, we want to say that if, if the script dot UI elements and at position I, if this one exists, and if the from the UI elements the element contains, but this is going to use kind of the bounds, so it contains screen point of the tab position, then we're going to, let's say, print. I'm going to print tab is over UI like this. And we're going to then return true. And otherwise, we will return false like that. All right, so let's make sure to save. And let's go into a logger. Let's clean all this here and simply reset. And then, of course, we'll need to go to the scene logic and actually add the UI elements. So let's add then the screen transform. And if you would have any further buttons or any other UI elements, you could add them here. So then let's test out. If we move around and toggle, we do see that tab is over UI. And if we tap not over the UI, we can place our hair. All right, so now finally we'll need to make sure that we can only place one of them. So then let's go here and say, well, if everything has been spawned correctly, should spawn is going to be set to false, like this. And then we can only place one. Cool, so we got stuff working. Now it's time to test this on our device. So now let's go ahead and send this to all devices after we've paired our phone and test it out. Cool, so this seems to be working quite well. And the only thing was that the toggle mesh button was too far below. So let's go to our screen transform and move this a little bit up. So let's go into the 2D editor. Let's grab the button and let's move it up like this. And now it should be working better. Cool. So next up, let's work on animation and hand tracking. So to add hand tracking, let's go to our asset library and let's search for hand physics. And let's add this template. This is going to make it a lot easier for us. And it's automatically going to add this prefab, which we're going to add under our camera object and which will enable hand tracking. And now to test out if things are working, we can do something pretty cool. And this is clicking here on the webcam preview. And now you can actually see me. And now I can wave at the camera and you will see that the hand tracking is indeed working. There seems to be like a weird offset from the hand, which we'll fix in a minute. But you can see that it's working. And also if we hold our hand where the cubes are falling, so this is the physics hands example, this cube will interact with the hand, which is pretty cool. All right, so let's get back to the simulation view here. And in order to fix the error, you can see that, well, there's this position of -40 in the Z. And I think if we'll just set this one to 0, I'm not sure why it is there. So now if we switch back to the webcam, we can see that things are working really nice as they should do. And the hand tracking is working great. It will even work better on device, but for testing purposes, this is completely fine. And so we can go on creating our hand interaction. So of course we will not need these falling cubes. So for that, let's go in the hand physics and then delete the examples here. So this is the hint text, the collider visibility. I'm actually not sure if we'll need that, but we can definitely delete the or just disable the hint text as well as the array of objects. Now let's quickly test this once more. And if we disable the collider visibility, I think also it doesn't seem to actually do so much, but what we can do, by the way, is we can go ahead and up here in the hand joints under the hand joints L and hand joints R, we can disable show mesh like this, show mesh, and now we won't see those, those spheres that we had. And we could also potentially, for later on at least, go into the hand mesh and go into the left hand mesh here, and then disable the show collider. And for the right hand, we can do this too, disable show collider. And so we won't see anything anymore. So if we want to deploy our AR experience a bit later on, you guys can do that in order to, well, make the magic even more magical without any visible mesh here. All right, so now we got hand tracking working, and next up we want to work on animations and the interaction in between, well, our hands and our 3D model. So let's do that. So let's create a new script. For that, let's click here in the asset browser on scripts, and let's create a new asset, or better, let's just click here on the plus. It's faster since we can search. So let's create a new JavaScript, and let's call this one hand interaction. And we can open this up here in our code editor. So first of all, what we want to do is again define some inputs, and in a second we're going to put like a indicator. So we're just going to take a sphere or something and put an indicator on our hand, because the idea of the hand interaction is that if the hand is open and facing towards the hair or our object, whatever we want to use here, that will then just change the color of the sphere, for example, from red to green, so that we can see kind of that the gesture that we've been thinking about is successfully being recognized. So let's make the input a scene object, which is, well, inside of a scene, right? So it's not a prefab, but it's within this scene hierarchy. And let's call this one sphere or indicator sphere. And then we're also gonna need two materials. So we're going to say asset dot material, and we're going to take the normal material. Let's call this normal mat, and we're also gonna take the second material, and let's call this one the recognized material. So then we'll also want to declare a global variable, and this one is something new. This is basically a variable that will define in the hand interaction script, but we'll also be able to retrieve this variable from any other script. It's like a public static variable, if you want to say so. And we want to call this one hand palm is open and points up. And this one will go then true or false depending on whether the gesture that we kind of define is going to be recognized. So then next up, let's create the function on update. And this one will call basically subscribing to the update function. So it will run once at any given frame. And so we're going to say if global.hand tracking, and this is actually a, well, another public static variable or instance that we are referring to here to the hand tracking, which is going to give us information about, well, the position of the hand and the position of each single joint and so on. And we can just retrieve all of that information and based on that do something. So then we'll tap into the get hand method here. Then we're going to store the hand information, which is the global.hand tracking get hand. So first of all, we'll make sure that actually there is hand tracking active and, well, we get information about our hand. And we're gonna do another double check here. So if the hand information is undefined for some reason, then we're gonna return, so to avoid errors. And then we're gonna say if, and this is going to be a function that we'll write in a second. So we're gonna say if wrist pointing up, and then we're gonna pass in the hand information. And then we're gonna call a method that we'll also write in a second, which we're gonna call setSphereMaterial. We're gonna take the selected material or the recognized material that we'll define. And of course, we're also gonna set our global variable. So the hand palm is open and points up. We're gonna set this one to true. And so otherwise, so else, we're gonna say that we want to set our sphere material to the normal material. So gonna go into the script. So the serialized variables up there, and we're gonna take the normal material. Don't forget our semicolons, and then also set the hand palm is open and points up to false. And maybe we're gonna call this method is wrist pointing up and hand open. So yeah, this is very long, but still kind of descriptive, and maybe other people would, well, understand more easily what this method does then. And so then, of course, if we don't have any hand tracking active, then if, well, we had set our global variable of the hand palm is open and points up to true, then we want to set this to false. I'm not going to write this another time, just going to copy and paste it. And we're also going to set our sphere material then to script dot normal material like this. So next up, I want to write another helper function, a global helper function about the hand interaction. And this one is going to return the distance of a certain object to the hand. And because later on we're going to check whether our hand is close enough to our rabbit. And for that, let's define a global function. So global.get distance to hand. And this is going to be a function. And it's going to take a position. And so what we're going to do is we're going to take the hand information. It's going to be the global hand tracking and get hand. Again, these methods you can find in the documentation of Lens Studio. Then we're going to create a max distance, which could be something very high. And if, of course, the hand information is undefined, so if there's no hand tracking going on, we're just gonna return the distance, which would be too far away or very far away. So this would mean basically that the hand is nowhere close to the object. Otherwise, we're gonna go and return from our hand information. We're gonna go into the wrist. And then we're going to go and take the position, and we want to then take the distance to the position and return this. So this is basically a internal method. So we're going to the hand information, which has all of these informations here. So we got the wrist and thumb and so on. And then we're going to take its position as a vector 3, and the vector 3 has the internal method of a distance, which then will return, well, a number which defines the distance. All right, so next up, let's create a new method. And this one is going to be our method that we defined up here, which is the isWrist pointing up and hand open function. So let's copy paste this one here. And we're going to take as a input, we're going to take the hand. And so let's make a quick security check here. So if we actually do have information within hand, so if it's not null, then if we don't have any information, we're just gonna return false. And then we're gonna retrieve information. So first of all, we wanna then go ahead and retrieve the wrist rotation. And let's say, okay, we got the hand.wrist.rotation. And then we're gonna set the threshold for the pitch. So pitch threshold. So we'll define kind of the boundaries in which we want to say the hand is pointing upwards. And the same thing we're gonna do for the yaw, which I probably did not pronounce correctly. So please hold on with me here because I'm not a native English speaker. And then next up, we want to find out whether the pitch and the yaw is within the threshold. So we want to define a new variable and call this one is pitch within threshold. I'm going to say that if the wrist rotation dot x is smaller than our pitch threshold, and the same thing we're going to do here for the yaw. So is yaw within threshold. So we're going to for that take the wrist rotation dot y and our threshold here of the word I'm not gonna pronounce one more time. So then next up we want to check the distance of the fingers. So now we would know whether the wrist is pointing upwards. However, we also want to check if the hand is open. And one easy thing to do is to check the distance between the ring finger and the thumb, because I don't know about you guys, but I can't open my, just stretch out my ring finger without opening my hand a lot. So we can use that, well, as some kind of indicator. Of course, if you want to make it even more precise, then you could potentially check the distance in between all fingers. But to keep it simple, we're going to just do it with the ring finger. So first of all, if we do not have hand dot ring finger, or we don't have a hand dot thumb, then can print hand has no info about ring or thumb finger, like that. And we're going to return false then, of course. So let's quickly do that, return false. And otherwise, we can go ahead and retrieve the positions. So we're going to take the ring finger tip, would be then the hand dot ring finger dot tip dot position. And we can also take the thumb tip, so thumb tip equals hand dot thumb dot tip dot position. And then we're going to calculate the distance between those. So we can then take for example, the ring finger tip, and then just say distance to thumb tip, like that. And so then we're going to also define a threshold for that. So the open hand distance threshold. And we're going to set this one to 0.05, like that. All right. So then we want to say is hand open. So declare one more variable. And we're going to check whether the distance is bigger than the open hand distance threshold. So then finally we can print all of this. So we could say the wrist rotation x, so the pitch, and then we're going to go with the wrist rotation dot x, and we can also print the wrist rotation y, which is going to be, you know, and we're going to take the wrist rotation.y. And finally, we also want to print the ring thumb distance. And this one is going to be the distance. And then we're also going to print the is hand open. And this is the is hand open. All right, so finally we want to then return if the is pitch within threshold and whether is yaw within threshold and is hand open. So if these criteria are true, then we're going to return true, and otherwise we're going to return false. So then before we test it out, let's go ahead and also implement the setSphereMaterial function. So for that, let's create a new function, setSphereMaterial. I'm going to take a material as an input here. And then let's go ahead and set the mesh visual, which could be script ball.get component. And then we want to get the component of mesh visual. And then if there's a mesh visual, so if we actually found something, again as a safety, first of all gonna take the mesh visual and we will clear materials. And then we'll also add again the mesh visual.add material. We're gonna add a material that we just took as the input for this function, like this. Otherwise, we're gonna quickly print something. Gonna say no mesh visual component found, like that. So then, of course, we'll still need to bind the onUpdate function to the actual event. So this can be done somewhere below here. And we're just gonna, again, create a event binding. So we're gonna say update event function as a variable. I'm gonna bind this to script.create event. And here we have the update event. And we're gonna bind the update event function then to our onUpdate function up here. So this means anytime a frame is being rendered, so something like 20, 30, 60 times per second, we're gonna run, well, this onUpdate function and check whether, you know, our hand is doing the correct thing that we wanted to do. So now the only thing left to do is to create the actual sphere and the material. And by the way, in this tutorial, we are only going to do one hand. So we're going to just do the right hand as an example with the indicator sphere as well. You could potentially do it with both hands and then drag in two indicator spheres that we're going to add to the hands. And then also later on do the distance checking and so on with, well, both hands, but as this tutorial is already getting a bit lengthy, we're just going to focus on one hand, but of course it's possible to do it with both. All right, so for that, let's first of all go ahead and create a new material here. So go to materials and we are just going to create a simple PBR material. And let's call this one indicator sphere normal. Matte, like this. If we click it, we can set the base color to red, so which means that, well, the hand is currently not in the position that we want to do something. And let's duplicate this one. So right click, duplicate, and let's call this one, how did we call the material? recognized. So recognized mat, like this. Cool. So now let's create a indicator sphere, and we're gonna do this under the right wrist. So wrist R. We can create a new object here. So click on the plus and let's enter a sphere. And let's call this one indicator sphere. So if we put on our webcam and test it out, we can see that, well, there's this indicator sphere. It's a bit big. So let's reduce the scale to 2 or something. And yeah, so it's enough to see. Maybe make it 3 so it's better visible in the video. But we do now have the indicator sphere. So then let's add the script to our scene logic. And let's drag in the indicator sphere from our hand tracking. So it is right here. And let's drag it into the scene logic like this. And then let's go ahead and take our materials here. So we do have indicator sphere normal and recognized like that. All right, so let's do a final check in our script if things should be working, and also make sure to always save. So just hit Control and S to save your project, or Command and S, and let's go to the script editor and let's check. So this is actually, I don't know why I wrote ball here. It's of course not called indicator sphere. So let's change this. We'll probably get a error message otherwise. But besides that, I think it's looking good. So then let's change to our webcam again. And we can see something printing here. So is hand open true and so on. So this looks pretty good. However, there also seems to be an issue because our sphere does not change its material. So no mesh visual component found here. Let's see why that is. Oh yeah, and of course it is a component and not a component. So we're making up a lot of new words here today. And let's try it again. Oh, and yes, we can see, well, it's red. Pretty good. All right, and we can also see that is hand open returns true, while probably the whole is pitch within threshold, is yaw within threshold, and so on is not returning true. If we close our hand, I just wonder what will happen. The hand is then closed, but still is hand open. So the ring thumb distance is 6, we can see, and if we open it up, it's getting to 15, and so this is only 2. So we could say that if the ring thumb distance is below something like 10 or maybe 12, then this means that the hand is closed. So the threshold here of 0.05 was very wrongly estimated, but that's, well, how it is. So if the distance is over 12, then the hand is open. So let's test it out again. So now the hand is open is false, and if we open up slowly, at some point it is true, and this is quite nice. But of course it's not pointing upwards, and this is a bit hard to test within the webcam, so we might want to test this either moving the webcam or putting it on our phone and see what's happening then. So let's do that right now. So I actually have here my phone wirelessly connected to the computer, which is quite nice if you have an iPhone and a Apple computer. But of course, you could also just, move your webcam or do whatever. And this is really a nice way to test out hand tracking. We can actually see here that, well, the values of the pitch and the yaw are actually on minus something. So we also need to adapt the thresholds here. So let's quickly do that. So this is always, some kind of experimentation here. And I'm glad we're doing this within the tutorial, because when you'll try out and do your own things, you also have to build, your own debug and experimentation test scenarios. So doing it like this and logging these values is a great way, well, to learn more about how things actually behave. Alright guys, so after trying around with it and wondering why it's not working, setting the threshold to 100 and even logging whether, well, it's within the threshold and so on, well, the error was actually that we forgot to change the indicator sphere recognized material from red to green, of course, which is supposed to indicate that, well, the hand position is reached. So let's quickly do that. And let's go ahead and set the threshold back to something like 0.5. And now go ahead and test it. We can see that this is working, this is not working, this is not working, and this is working. So we do have, apparently, I mean, if we do this, the hand is not open too, but apparently we do have it kind of working. And if we spread out our hand like this, then we have a simple gesture recognition system, which is a really great achievement. So if you made it this far, pretty proud of you. Not so easy. And now the only thing left to do is then to have our rabbit jump on our hand, well, if the gesture is recognized. And this is what we're going to do next. So first of all, we want to go into the asset library and want to search for state or state manager, and we want to import and install the animation state manager if it isn't already installed in your Lens Studio, because this is what we're going to use for animations. So the next up, we want to go into the asset browser, click plus, and search for the animation state manager, and simply going to create one of those here. So then we want to go into our rabbit animal, and let's collapse these here. And then we want to go onto the rabbit animal, and we want to click plus and create a new scene object here. And I'm going to call this state manager. And then as a new component, we want to add the animation state manager below. And then we can already go ahead and see that at the parent object, we do have an animation player with all our animation assets in here, and these are the ones that we'll find in the folder, and then with these purplish icons here. So it might not happen with all objects that you choose to import, so you might gotta search within your corresponding object if you're gonna find those, and then add the animation player and define also a name for the animation. So then we want to go ahead and drag into the state manager the parent object, so we have the animation player attached. And next up, what we want to do is we want to set up the animation states, and for that we want to edit animation states, custom states. We're just going to add a few values here, so we're going to use 2. We will use idle and walking, or a walk, and then we want to take a look on how these are called here. So we have idle and walk, so these need to correspond, these names of the animation assets need to correspond to whatever says here in the state manager, so the animation clip. And to keep it easy, we're just gonna copy and paste the name. So we have idle and walk for that. And that's it, what we need to do right now. So then next up, before we're gonna create the behavior of the rabbit, we're gonna go into our script editor, and then in our hand interaction script that we created early on, and we just create a little global helper function. For that, we're going to create a new input like this. And we're going to say we want to input a scene object, and this is going to be our right hand wrist position. And so this is basically the scene object of our well, hand representation that we want to parent the rabbit to if it reaches the hand. And then we're going to say global.get hand parent scene object. So we're going to create a new function that we're going to call like this, and that we can basically easily call from any other script. So we want to get the hand object that the rabbit is going to be parented to. And this is going to be a function which is going to return. And then we want to return script dot right hand wrist position, like this. And so in this way, we can call this global function in another function, which will be the behavior of the rabbit. And then we can simply get the parent object when we are close enough to it. And so, of course, we need to assign this as well. Let's go back to our scene. We can scroll down here and double click on the scene. And then in the scene logic, what we want to do is we want to assign, so under the camera objects, we got our hands here, and then we're just going to take our right hand wrist or wrist to thumb. So these will all be the different points on the hand. We can just try it out. Could also go wrist to mid, for example. Just take this one and drag it in. All right, so now we assigned our right hand wrist position that we want to, that we can use to parent something to. And now it's time to write our final script. So let's go for a new JavaScript, and let's call this one animal behavior script. And let's already go ahead and actually do a double click here on our rabbit animal and just drag and drop this one actually on our object. So animal behavior script like this. And always make sure that if you do some kind of changes to these prefab assets, that you click apply once you're done, because otherwise it won't be saved, or at least it won't be applied when it's being used within the scene. And so let's double click on the animal behavior script, and it's missing an A. So one more word we're going to make up today. So one last word, it's the behavior script, but we want to make this the behavior script, of course. So let's begin by creating our input. Once again, for that, we want to go into the components, and we want to take a script component, which could be anything basically, but this time it's going to be our animation manager that we created, so the state manager. And we want to define, first of all, a few variables. So one will be the walk speed, and this one we can simply set to something like 0.4 or so. This is all something that we'll need to experiment. So then let's also define the close by threshold. And this one will be, let's say, something like 50. And this will define whether our hand is being considered as close to our object, to our rabbit. And this is, again, something we need to try out simply. And the arrived threshold. So this one is going to define whether the rabbit sits on the hand actually. So if it has arrived there, basically. Then we're going to do some other variables, which will be is walking. So are we already walking towards the hand or not? And did we reach the goal? So has reached goal. This one's false. And then finally, we want to say was parented to hand. So this will be kind of our final thing here. So if it arrived and has been parented. All right, so let's start with our onStart function that we want to define. So all we got to do here, all we want to do here is we want to actually play an idle animation. So we will define a method later on, but let's call this one play idle animation like this. And next up, we want to create our next function, which will be onUpdate. And this one is first of all going to ask if, well, it has been parented to hand. So if we're pretty much done, then we want to return. We don't want to do anything anymore. because we've already achieved our goal. And so if then we haven't reached our goal, so this is kind of the next best thing, then we want to say if, and we will define this a bit later on, but if is hand close, so we'll find out whether the hand is close to our rabbit. This is a function we're going to define later on. We will then retrieve the hand position. And we're going to go into our globals here, and we want to get hand parent scene object. So this is what we just created in our other script here. And then we will call two functions that we'll also define, and one will be look at hand, so that the rabbit looks at its goal basically while walking. And we're going to feed in our hand position, and we want to get the transform, and then we're also gonna get the world position like this. And next up, we wanna create another function to walk towards the goal. So walk towards goal. And we're gonna take again our hand position and then the get transform like this. All right, so then if we have reached our goal, we're gonna go else. So then we're gonna set hand parent. So we're gonna parent rabbit to the hand, and we're gonna play the idle animation. And we're also gonna say was parented to hand equals to true, because then we're done. So then next up, let's write the function set hand parent. And for that, first of all, before we're gonna parent the rabbit to our hand, we wanna store its scale, rotation, and position, so it won't inherit these from the hand object. So for that, we're gonna create three consts. So old world scale, we could say. Then we want to simply get the transform of our current object, and then we want to get the world scale. And so we can then go ahead and duplicate these lines basically. So twice more. And then we can go ahead and set the old world position, and of course the rotation. So get old world. So the old world position will be the get world position, and then the rotation, of course, will be the rotation. So then next up, we'll do the parenting, which is also quite easy. We're gonna go into the script, we're gonna get our scene object, and then we're gonna set parent, and we're gonna go and get our global get hand parent scene object. This one here from our global function that we defined. And then all we gotta do is then reset our position. So we're gonna go script and get transform, and we're gonna set our world position to the old world position. And then, of course, we're going to do the same thing to the scale, transform, and rotation, and so on. All right, so this is the set hand parent method. Next up, we want to go ahead and create a new function, and this will be the look at hand function that we already called a bit earlier. And here we're going to get in the target position as a variable to pass in. And let's begin by creating a new variable that we want to call source position. And for that, we're going to go and get the script and the transform and our current world position, like this. And then we also want to go and get the direction. And this is something we're going to calculate using the target position, and we're simply gonna subtract the source position, and we want to normalize this one like this. And then we'll also need our up vector for the look at method that we're going to call in a second. So we're going to take the vec3.up. And so then we're going to calculate the rotation. And this is simply going to be quaternion. And we're going to look at the direction and the up axis. And then finally we want to set the rotation. So get transform again and set world rotation to our rotation. Nice. Okay, so next function. So we're almost done. We are pretty much at half, I would guess. So bear with me. We're almost there. We're gonna go is hand close. And for that, first of all, we wanna get our self position again. So self position, which is going to be the, again, get transform. And we wanna get the world position. Let's do a little security check here, because we're always asking above here if the hand is closed. So this might be also the case if there's actually no hand in the scene. So we want to just ask, well, if the self position, if this is undefined, so if there's no hand, then we want to just return false. And otherwise, we want to go ahead and go into our global function, so the get distance to hand that we wrote a bit earlier, and we want to put in the self position. And if this one is closer than our close by threshold, and of course we want to go into get the global variable. So if the hand palm is open and points up, this is the case, then we're gonna return true. And otherwise we wanna return false. Alrighty, right. So next function, we wanna have the function to walk towards the goal. So walk towards goal, and we're gonna again get the goal transform as a input. And then we want to go ahead and set the self position once again. So script, want to get transform, and we're going to get world position. And then we also want to get the position, which will be from the goal transform, and then get world position. All right, so now we have our position and the goal. Then next we want to calculate the distance to target. And this one is going to be the self position, and simply calling the distance function here. And then we're going to put in our goal position, so our position in this case. So then we want to check that if the distance to target, if this one is bigger than the arrived threshold, well then we want to set the direction to go, so const direction, which is going to be the position, and we're going to subtract the self position, and we want to normalize this one. So we do have basically the direction that we want to move towards. Then we're going to store the progress. We're going to say we're going to go for the walk speed, and we're going to multiply this by the time.delta time, and this is basically a way that will make sure that no matter how many frames per second we'll have, we'll always have the same walk speed, as will multiply by the time which has passed from one frame to another. So This way we get a smooth experience. And then we're going to create a new variable that we want to call new position. And this one is going to be a vector3 lerp. So we want to lerp in between those points. So it's a linear interpolation. From the self position to the position, I'm going to put in the progress. And so each time this is called, we're going to move a bit further towards our goal and have a smooth walk from one point to another. And then finally, we want to get the script transform, and we want to set world position. We're going to take in our new position here, like this. So then if we are currently not walking yet, then we want to play our walk animation. Like this. And we want to also set is walking to true, so we will not play it once more anytime this function is being called. And well, if this is not the case, so if the distance target is not greater, then that means that we are very close to the hand. So then we want to simply set has reached goal to true, which will make sure that we'll then parent the object to the hand. So then finally, we want to write two very short functions for play idle animation. And here we want to go into our animation player. So anim manager, want to set state. And here we want to set this one to idle. So we're triggering the idle animation. And we could also go ahead and, for example, print and say setting state to idle. And then we could also go ahead and say play walk animation. So we also got this one. And then we can go ahead into our animation manager, set state to walk, like this. And then of course, print setting state to walk. All right, so now we only need to bind this to our event functions. So create two more variables on start event, and want to go into script.create event. So let's put in the on start event. And then of course we want to bind the on start event to our function here on start. And then finally, we also want to do the same thing with the update function. So on update event, like this. And then we want to go ahead and say equal script create event on update. I think it's just update event. Yeah, that's it. So then again on update event bind towards our on update function up here. So after doing a little bit of testing, I actually did find out that the vector3.up here is indeed a function and not a property. So we need to call that accordingly with an opening and a closing bracket. All right, so now it's time to test this on our device and see if things are working. However, what you guys can also do, even to get more of an idea of if things are working, you can go into the scene and then under our orthographic camera and the full frame region, you can add something like a text, for example, or a screen text. And then you can go ahead and, well, based on whatever state the rabbit actually reaches, for example. So if we have is walking true or has reached goal true or whatever, change the text on the screen so that you guys know what's going on. You could, for example, go ahead and set a new global variable here, which is then a string, let's say, and then this global variable will be updated anytime that, well, something happens here. And then within the scene, you can add another script which will then on update anytime while the global variable isn't null, or maybe we will initialize it with something, will update as well, and then give some information on the state and what's going on. So this is a great way to test things out. All right, and as we can see here on our screen, things are working like butter, and we got a pretty cool AR animation and interaction effect done. So to publish the lens, we can click here on publish and then do a few settings. So we can give it a name, and then we're gonna set what it's made for. So mobile web spectacles, which is this AR glasses from Snapchat. Camera kit is when we want to use this for iOS or Android. Then we can see whether our lens size is fine. So it needs to be under 8 megabytes. And finally, do a few more settings such as the icon. We can also generate something and also create a preview. So we can, for example, record something on our phone. And then finally, we can hit on published. And once this is done, we'll actually get to this page here. And here we can administrate and manage all of the lenses that we created. So if you publish your lens, you will see it somewhere here in your lens folder, and it will say something like waiting for review. So all the lenses will be reviewed, and after that you can pretty much share it or make it visible and use it within your Snapchat. And if you want to publish your lens not only to Snapchat but also as a web AR lens or maybe as a native experience, you can do this here too, and then generate a URL for your lens or integrate it into your app. But this would be a topic for another tutorial. So the current lens we built is mainly thought to be within Snapchat. Alright, but that's it for this video. So I hope you liked it. I hope you find it useful. If so, then please consider subscribing to this channel and giving the video a thumbs up. And if you want to see more tutorials on Lens Studio, then please leave a comment below and tell me what specifically you want to see next. But until then, as always, thanks a lot for watching and see you next time.